So picking up with number 21, we are now solving the equation. And so what they want us to do is at the end, we should have a value for y. So we'll have y in this case because we're working with y. But if we were dealing with x, then you would have x equals some number or y equals some number in this case. And so the first thing we want to do is actually not too dissimilar from what we were doing with the previous section, which was finding a common denominator. Except in this case, what we're going to do is once we have identified the common denominator, we are then going to multiply each term by that common denominator in an effort to clear the fraction. And I think that'll make a little more sense when we go through it. So I'm going to go ahead and rewrite the equation here. So 6 over y plus 4 minus 4 over y minus 4 equals 4 over y squared minus 16. All right. Again, we want to try to find a common denominator. So let's go ahead and factor each denominator in an effort to identify what factors are making up each denominator, and so we can kind of build a common denominator. Y plus 4 can't be simplified, so there we have it. Y minus 4, again, we can't do anything with. But y squared minus 16 we will probably recognize as being the difference of two squares. So we have y plus 4, y minus 4. Well, this y squared minus 16 has both factors already incorporated in it, doesn't it? And so since we know that the common denominator has to have one of each thing that is unique, and we're only dealing with y plus and minus 4, this must be our common denominator. And so once we've, again, identified the common denominator, we are going to multiply each term by that common denominator. Or you can also think of it as multiplying the whole equation by that common denominator. So I'm going to go ahead and write the common denominator, y plus 4, y minus 4, above each term, y plus 4, y minus 4, and again, y plus 4, y minus 4. And this acts again as multiplying the whole equation by that common denominator. But I like to actually write it above each term so that I can physically cross out which denominators are being eliminated, and then so I can visually see what I'm left with. And I think that'll make more sense here in a minute. So let's go through and actually do some of this multiplication. Well, y plus 4 cancels out, and I'm left with a y minus 4. And so I perform the operation multiplication with what's left. So 6 times y, that gives me 6y. 6 times negative 4 gives me minus 24. And then we have this minus. And so let's go ahead and actually, before we deal with that, let's cancel y minus 4 and y minus 4. So now we can go ahead and perform the operation multiplication with what's left. So we have negative 4 times y, so minus 4y. Minus 4 times positive 4, well, that's negative 16. And there we have it. And then our equal sign. And y plus 4 goes away. Y minus 4 goes away. And so we're just left with what's left, the 4. Let's go ahead and combine some like terms wherever we can. So we have 6y minus 4y, so we have 2y. And we have negative 24 minus 16, so we have minus 40 equals our 4. And if we're going to go through, now we have just a basic equation, basic algebraic equation that we're trying to solve for y for. So add 40 to both sides. That leaves us with 2y equals 44. And now we'll subtract 2y, divide rather by 2. So that we can isolate y, and that leaves us with y equals, well, 44 divided by 2 is 22, and there we have it. Y equals 22. And now what you really want to do is you want to get in the habit of going back, taking what you believe your solution to be, plug it in for y, and make sure none of the values of y, because in some cases we may end up with multiple values, right? We may end up with 2 or 3 answers for y. We want to make sure that none of the answers, the solutions that we come up with, make any of our fractions undefined. Meaning, if we were to take this value of y, plug it in do we get a 0 in the denominator for any of these fractions? Well, let's see. We're saying y is 22. So 22 plus 4 is 26. Works for that one. 22 minus 4, 18. So that works. 22 squared minus 16. I'm not sure what that is, but it's definitely not 0. And so it works for that last fraction. All right, so that's what you want to do. You want to make sure that when you actually solve for your variable, that solution doesn't invalidate any of your fractions by making the denominator undefined. So if we were to, for example, have solved for y here and our y answer was 4, when we plug it into this first fraction, we get 4 plus 4 is 8, and that works. But here we would have 4 minus 4, which would give us 0, and we can't have a 0 in the denominator, so we would drop that y equals 4 as being a possible solution. So you can just exit out, and either the answer is no solutions, or you will take what solutions are left. And again, it probably doesn't make too much sense because we're not actually seeing that, but when we get into some of these further questions, I think we'll run into a couple different cases where what I'm saying will hopefully make a little more sense. So I'll go ahead and end here, but when we get there, explain it again. All right, but in this case, number 21, y equals 22.